7, 6, 5. Good morning, class. Welcome to our usual maths class for grade 11, now in a new time slot, 9 o'clock. I hope you guys are also as appreciative of the time slot as I am, and I'm happy to be seeing more of you joining me. I am Miss Shabalala. You guys can get a hold of me on Twitter at _Mbaliti, and I've been taking you through some grade 11 trigonometry. So we have finally reached the last topic under trigonometry, after which we will do a bit of revision here and there before we continue to our next topic, right? First things first, the usual, my regulars. Welcome, guys, as always. It's always great to be with you. Thank you for following the classes so diligently, and I hope we've all been doing well to keep up with each other. To the guys that are new, we've got some rules of engagement that we go by here, and I'm hoping that you too will become a regular and join us constantly, such that you'll even cram these rules when I put them up. I always have to put the rules up because we always have new joiners. Hope you guys can bear with me. Our rule number 1 says, respect everyone because we're all here to learn, right? Rule number 2, there's no such thing as a dumb question, so please feel free to ask away. Rule number 3, please raise your hand, and this should be hand, guys. Please raise your hand, and you will be unmuted when you can ask your question, right? For those of you, so this one is particularly important. Please keep your cameras and your videos off, guys. Please, pretty please. For those of you who are shy to raise your hand, please do type your questions in the chat, and I will gladly answer your question as well. Right? As a point of reference, when we ask questions, guys, in case there's a minor delay that neither of us are aware of, please make a reference point to your question. So let's say I'm doing a slide on the sine rule like I am today. Please say to me, on the first slide of the sine rule, you said ABC, and ask your question. So please always refer back to where you are getting your question from. That'll assist me in being able to answer you quicker and more effectively, right? Next, we will not tolerate vulgarity. This is especially in your chats, guys. The purpose of the chats is for us to engage about this class. It's for us to ask questions and for anyone who has an answer to provide an answer, right? This also goes back to number 1. Please don't take the opportunity to learn away from someone else. And lastly, please extend the link to your friends for them to join in as well. I think the bigger the group, the better we can do in terms of what we cover for class, because I would like to prep you guys for when we prepare to go to school, because at the moment we don't know when that will be, right? So yes, what is the plan for today? As I stated yesterday, and I didn't give you guys any homework yesterday, today's plan is as simple as going through the area rule, the sine rule, and the cosine rule. This, as I had mentioned, guys, this is our last topic in the trigonometry section. After this, we will be spending a few days going through question types across the trigonometry syllabus that you could get asked in your papers. What I would like to ask of you guys is, please, if you've got particular questions that you would like me to do in the class, please send me those questions. That would mean quite a lot to me, right? Okay, as we begin today's lesson, right? Let's start with the area rule. Do you guys remember how to calculate the area of a triangle? Just from your normal area calculations. I believe we started calculating area in primary school, and there was a formula for the circle, like pi radius squared. There was a formula for your rectangle, length times breadth, a formula for your square, side squared. Does anyone remember what the calculation was for the area of a triangle? No takers? Okay, guys. The area of a triangle is calculated as half base times height, right? The base being one, so your height is the perpendicular height, your 90-degree height, and because we've always to date assumed that our triangles all have a perpendicular height, and your base is basically your bottom or your under side of your triangle, right? So I pose to you this triangle and I say to you guys, please calculate the area of this triangle for me. Any takers on the calculation of the area of this triangle? No takers. Okay, guys, what I need from you, please, is signs of life, signs of engagement. I'd really appreciate that. But our area of our triangle here, if we apply the formula half base times height, here's our base right here. See, let's switch from yellow to red. Okay, this is our base right here. This is our entire base. And this perpendicular, this is our height. So half base times height will be, you'll be substituting your 10 in there, you'll be substituting your 8 in there, and that your 6, apologies, and it gives you 16 divided by 2, which gives you an area of 8 square centimeters. All right, guys? So what have I been saying that we've always known about the height in this formula? I've actually literally deliberately been mentioning it. Does anybody know what the case of the height in this particular formula is? Right, guys? In this formula that we've been using to date, the height has to be a perpendicular height. So it has to be a 90-degree height, right? So what we have previously done in the past, maybe you were given this side or you would be given this side as a measure, and you would be told, and you'd also be given the side, and you'd be told to calculate your area. So because this was perpendicular, you would apply Pythagoras over here to get this side. Then for this side, you have this side and this side. And that's how we go about finding area, or even finding the sides of the triangle. We used to basically I'll call it taking the long way around. And so now the area rule under trigonometry poses you with a way to calculate the immediate area, right? So guys, what happens when there is no perpendicular height? We use the area rule. The area rule is the one time where we are able to calculate the area of absolutely any triangle. I mean, if you want, you could even apply the area rule to a 90-degree triangle. It's just that we all know what the sine of 90 is, I hope. So someone is asking me if the area is not 30. Please tell me how you found that the area is 30. Imita is saying that the area is 30. Please take me through how you arrived at the area being 30. You multiplied 6 and 10. Aha, I see. Right. I actually see my error. Aren't you just the best? Here is the error that was made. Okay, I see. Okay. Here's the error that I made, guys. I added it's half base times height. I actually, in my calculation in my head, added I see exactly where I went wrong, Anita. So please, please be blessed because you are absolutely correct. That gives us 30 centimeters. Thank you so much for being woke this morning. I absolutely missed that because I added and I should have multiplied. Guys, please accept my sincere apology for that. And this is also why your engagement is so important, because I won't see every error that I make because, wow, I've been in maths. So thank you so much for that. Thank you so much for that. Thank you so much for that. So yeah, guys, so I'm posing to you that the area rule is applied. Thank you so much for that. Shoo. I'm posing to you that the area rule is applied when there is no perpendicular height. So you have a triangle, you need to find the area of the triangle, and you do not have the perpendicular height, right? This is literally the rule, right? And it applies however dimensions you want them to, in whatever dimension you want it to apply to, right? So where we have ourselves a little perpendicular situation over here, we've always used our half of A times H. I can't tell you enough how much you've just shown me some light that I missed. Thank you so much for that. Right. It's half of A times H, right? That's how we always do it when we have a perpendicular angle, right? But now, remember that H is a side in our triangle. Let's give or take say that this is our triangle, right? And we are using this triangle because we could actually use any triangle. Let's start with this triangle. I'll work in red, right? So let's hypothetically say that we have been given our hypotenuse, which is B, and we are searching for the length of side H, right? Side H is an opposite side to the angle we are working with, right? So that means that to find the opposite, and we have the hypotenuse, we are going to be using the sine function, right? So that means that H is equal to our hypotenuse. H is equal to, so when we substitute, we're going to say H, because that's what we're looking for. Our hypotenuse is B, and we say that is equal to sine of C. So when we simplify the value or the length of our side, our height, it's H is equal to B times sine of C, right? So this is me saying to you, basically, that when we are applying the area rule, we are ultimately going back to find the height of the triangle. What we just have differently this time is that we are not under the assumption that we are working with its exact height where it's 90 degrees and everything is given, right? The same is, let's say you were working in, let me swap this around, this triangle, the green triangle, right? In the green triangle, you have your hypotenuse here. So you don't know how much your adjacent side is, but you can find H, which is your opposite side, right? And when you apply it in that way, so you almost switch everything around, you would say that H is equal to C times the sine of angle B, right? Hoping that makes sense to you guys, because the point I'm trying to drive across is that in any given triangle, that's how you apply, right? What I wish to absolutely mention here, what I'm not going to call it an error, but what tends to happen is what we tend to miss is where the angle that we are talking about is sitting, right, guys? So let's use this triangle over here, for example, right? For me to be able to use this triangle, this area rule can apply in any direction. You can use it to say, let's say half of, right, let me say A let me make A the base, and then let's make B the height. Let's use B as our reference point for the height, right? So it's going to be what's opposite B, angle B. So we'll be saying sine of B. And what else is a known angle to us? It's C, because we're going to be looking for B, right? The point that I'm trying to drive across, guys, is no matter how many directions you flip this in, you could decide and say half BC sine A, right? All these three should give you the same answer because it is the area of the same triangle. So what I'm basically saying is in any given triangle, the area is equal to half of A times B times sine C. It could even be half of B times C times sine A. And it could even be half of A times C times sine B, right? You choose which angle you will be using. But what I wish to bring to your attention or to caution is you always use this angle that is within the two sides that you are using. So you see how, let me go back to a different color pen. So you see how in this case, in the first case, I used side C and I used side A, right? And the angle that I used was B. So what we know is that you must always use the included angle. Apologies for that, guys. Always use the included angle in your calculation. So if we were using A and B, then we would be talking about the sine of C, because that is the angle that is included, right? So we don't always have the liberty of having all the angles that we want or all the sides that we want. So we always look at our information to see what's available to us. If number one, we need to use that to calculate anything else, or number two, we can work with that to still get to the answer. Right, guys. So how does the area rule work? I've created a few class examples. This is example one of the area rule if anyone needs to make reference to this example, right? I'm giving you this triangle here, and I'm telling you that angle B is 50 degrees. I'm telling you that AB and AC are both 7 centimeters. I'm saying to you, please find me the area of this triangle, right? Very clear, we don't have a perpendicular angle, a perpendicular height, right? So first things first, the last thing that I had just said is we have to use an included angle. So what we have here is we have 7 centimeters here and we have 7 centimeters here. Does anybody understand or agree that we cannot use Pythagoras to solve for BC because we do not know whether this is a 90-degree angle or not, and we don't make that assumption? Does anybody agree with that? Right? So, but what we do know, guys, is that this angle here is 50 degrees. This is 50 degrees because we know the rules of an isosceles triangle. Opposite angles and opposite sides are equal, right? So we always have to use the included angle. That means we are automatically able to, once we have the other side, we are able to calculate our included angle, which is A. When we find the size of A, we simply say that the sum of all the angles in a triangle is 180 degrees. We substitute, so we're going to say A plus B plus C must equal to 180 degrees. So we'll substitute each relevant side that we have. We have side angle B as 50, we have angle C as 50, and then now we simply solve for angle A, which comes out at 80 degrees. So now what do we have with us? We have a side, we have an included angle, and we have a side. And ladies and gents, now we are able to apply our area rule. So now to calculate the area of triangle ABC, we're going to say the area of triangle ABC is half of B times BC times sine B, right? This should be A, guys. What am I saying BC for? What I tend to do a lot, if you guys remember from my previous classes, I had always said to you when we were doing, whether we were doing quadratic equations, but anytime I used triangle as an example, I said to you, there's always a relationship between an opposite angle and the side of that, whether you're measuring length or whatnot, right? For example, in this case, we all know that where whatever in an isosceles triangle, the opposite sides and angles are equal, right? That gives you the relationship between the two, between an angle and a side. So what I like to do is I would call this small b because this is big B. I would call this small a because this is big A. And I will call this small c because this is big C, right? That's how I name my sides to make things easier for myself. But you could have also easily just gone and said, guys, firstly, this is A. This should be A because A is our included angle that we're working with, right? So we could have easily also not complicated your life this way and just gone on to say half of AC times AB, right? You could also write it like that. More than happy for you to write it like that. This is just the way I use to make substitution easier for myself, but it's neither here nor there, right? You substitute your values accordingly and you have your sine of 80 degrees, right? So it's half of 7 times 7 times 80 degrees, times sine of 80 degrees, and you pull out your calculator, guys. So you're basically looking for the sine of 80 degrees, 7 sine 80 degrees, and you come out with an area of 24.13 square centimeters. Anybody have any questions on this? Everybody good on this example? I'd like to clear out all this. So what I want to say to you guys is in this particular instance, right? When I say to you, we always look at what information we have to see how far we can go in our calculation. In this particular instance, we had a side, and we technically had two angles. But the angles here were relatively irrelevant because they are not the included angle. You would still need to go and find the included angle, right? So the fact that we have this side and we know that this is an isosceles means that we can get to that easily. So the question is always, what do you have and what are you looking for, right? So what we could have done is if we were given side BC, we would not have needed to calculate what the value of angle A is because we would have had side angle B as an included angle that we could have worked with in the calculation. So our calculation would have gone something like half of AC sine B. That's what our calculation would have been. Okay, right, guys, that's literally all there is to the area rule. The same rule applies as you would in a perpendicular triangle. It's just that now you don't know that length. So you're going to apply your trigonometric functions to find that length. It's normally an opposite side, and that's why you use the sine rule. That's why you use sine as your function, right? Second rule is our sine rule. The sine rule is also a relatively straightforward rule that says that the sine of A over A. Remember what I said to you guys I do about naming my sides. Let me find a better pen. Remember what I said to you guys about naming sides? This is angle A, so this is side little a. This is angle C, this is side little c. And this is angle B, so the opposite side is side little b. All right? I like the sine rule for proving what I've been telling you guys over the weeks, and I've been saying to you over the weeks. The angle and the side always have a relationship that you can almost see instantly. So you can always use that relationship as a sense check for whether your answer could be correct or not, right? So anyway, our sine rule says sine A over A has the same ratios or is equal to sine B over B and is equal to sine C over C. So what I'm saying to you about this, I'm not saying to you that, let's say side A is 3 and angle A is 60 degrees, that it's going to apply the same way consistently the whole time. No. What I'm saying to you is, here, if we have a sine of 60 degrees, I'm trying to remember my table in my head that we've done previously. Any helpers for the sine of 60 degrees? Any helpers? Any helpers? So the sine of 60 degrees is the square root of 3 over 2. I've remembered from the table. It's our square root of 3 over 2, right? What I'm saying to you is that here, the answer for sine of B over B could actually also be 2 square root of 3 over 4, right? That's what I'm saying this could be. So you'll see that the answer in absolute form, the amount or the value is different, but the relationship is exactly the same, right? That's what I mean when I say to you these are equal. I'm talking about in relation, in proportion, they are the same. The relationship between sine A over A is the same as the relationship between sine B over B, as well as for sine C. That does not mean that this is all 60, 60, 60. No, that's not what it means. I'm hoping I'm making sense with that fact. So when do we use the sine rule? Number one, again, there is no perpendicular height, because if there is a perpendicular height, then the sine of 90 is 1. Then what are we doing? Because we know we just need to use 1, right? We also use the sine rule when we have 2 sides and 1 angle. This time around, guys, unlike the area rule, it must not be an included side. It must not be an included angle, right? So if I have side AC, and I have side CB, side C is not, angle C is not the angle that I'm using. That angle has no value for me in the rule, in the sine rule. And as we go along, we'll see why, as we do our examples. The other option is for me to have 2 angles and 1 side. 2 angles and 1 side, why? Because something I mentioned in a class last week, I always said to you, they could never just give you 1 side and 1 angle. The thing we are doing here is, in a triangle, the angles and the sides have a relationship. So what we are doing here is building on that relationship. You have to be given at least 3 bits of information, is where I'm going with this, for you to be able to establish a relationship of all the angles and the sides in the triangle, right? About the 3 sides, guys, the 3 sides is another rule altogether. That's the cosine rule. So for now, we're still here with the sine rule. And being given 3 angles, well, then you can apply any side you want to those angles, because you can almost tell more or less the relationship of those sides. You would have to have guessed 1 side or assumed 1 side for you to then be able to apply again this rule to calculate the other sides, right? Hoping that makes sense. So here's our first example under the sine rule to get us through how sine rule works, okay? Here we have our triangle, right? With our triangle, if you look at our information check of what I said you need, I said you can have 2 sides and 1 angle, or 2 angles and 1 side. What do we have in our case? We've got 2 angles and 1 side. So here, again, let me, for naming purposes, call this side T, call this side R, and call this side S. And I'm saying to you, we have been given 3 bits of information that are allowing us to be able to establish the magnitude of the relationship between the sides and the angles, right? So we have, in one instance, we have a side and an opposite angle. That will enable us to find the side and the angles of all the other sides, right? So here, let's say we are going to number one, start by finding lengths. Let's say I've given you this and I'm saying, let's please use the sine rule to find the length of TS, which I've now named R, and RS, which I have now named T, right? You don't have those lengths, but you're looking for those lengths. But you have enough information to give you a possible relationship for those lengths. Okay, number one, let's start by solving for the missing angle, because it's clear that the missing angle we are going to need when we calculate the length of TS, right? Our missing angle, we apply our usual sum of angles in the triangle rule, and we will come out at R being 85 degrees, right? Angle R is 85 degrees. And so that means now we have one side and we have three angles of our triangle, right? Then we go back to asking ourselves, which relationship between a side and an angle do we have and do we fully see? And that is the S relationship, right? We have the S relationship. So we can see very clearly that sine S over S can actually be given numbers as a whole. We see exactly how those relate, right? Remember, guys, sine S over S, or you can write it as S over sine S. It's really the reciprocal of the other. As long as you maintain consistency with what you're looking for, then it shouldn't be a problem with what denominator or numerator you choose. Okay, so here we said, which relationship do we have? We have the SS relationship, and it's S over sine S, right? And you've substituted in there. Our sine rule says that S over sine S is also equal to R over sine R, or T over sine T, right? Question? Okay, got it, right? So then we're going to substitute. So now we're going to first find side R, right? Which is TS that I have named side R, okay? We're going to substitute all the values that are available as we do normally in our equations as we've been doing to date, and we solve for R, guys. What we do on the left, we do on the right. That's our rule, right? So bam, bam, right there. Put it in a calculator, and we find the length of R being 46.5 centimeters, right? Everybody happy with my answer? Any questions on my answer? And now we have full information to do the relationship for the other side as well. So someone could then come and say, you want to find T over sine T. So you could say T over sine T is equal to R over sine R, now that you've solved for R, well, side R. What I'm going to say to you guys is always use your starting values that you were given, because that's the one time where you are 100% certain. Well, I mean, you could always be 100% certain. That is the one time that you are certain on the relationship you're using. So even when it comes to T, I would say to you, rather say T over sine T is equal to S over sine S. So maintain the use of sine S. Maintain the use of the relationship that was given to you in the paper, right? So we do then our usual substitution as we previously did, and we come out with T being 38.2 centimeters. Literally, guys, this is how the sine rule works. Take it, there's no questions for now. There's nothing that's been said yet, so it's relatively straightforward so far, right? Can anybody tell why I said that the angle shouldn't be an included angle? Does anybody know why? Let me go back a little bit. Right, guys, let's say we were not given, okay, let's say we were not given this 55. We were given this 85, right? Does anybody understand why? Okay, I've actually just remembered in our homework, there's a thing that's going to answer that question for all of you. So I'm going to leave you guys with some homework questions that we're going to do tomorrow in class, and that'll answer the question. I'm hoping from tomorrow, then somebody can come back and give me the answer. All right? Then our last rule, guys, is the cosine rule. Anybody who would like me to please prove the cosine rule outside the class, please do let me know. In our helpful links, I also have posted a link on how we arrive at the cosine rule. The starting point of the cosine rule, I'm sure you can see, is the Pythagorean theory. But because we don't have a perpendicular height, it does not, you have to switch it up here and there. Proving that rule will take a bit of time, and I thought, given that you guys are given a formula sheet in your exams, I didn't want to waste your time with this. But please, if anybody is interested in finding out how the cosine rule is arrived at, you have my contact on Twitter. Hit me up and I'll definitely show you how to go about that. Right? So the cosine rule, our final rule. How is the cosine rule apply? When does the cosine rule apply? Number one, as usual, we don't have a perpendicular angle. Number two, we again have three pieces of information, right? We have two sides and one included angle. And we have three sides only, right? If we can actually work with three sides to find the angles, because at that point, we have an understanding of how each side relates to the others. Okay. Here, simple example. We are finding length using the cosine rule. Okay. This is our triangle that I'm using, triangle PQR. If we want, again, we can denominate this as small q, small p, and small r, right? And we have been given what? We have been given two sides and an included angle, right? I'm saying to you, please determine the length of QR. So I'm asking you to find side P for me, right? We literally have all the values we need for our substitution, because here is our equation right here. A squared is equal to B squared plus C squared minus 2BC cos A. So this is something like, what I said before? P. So this is something like P squared is equal to Q squared plus R squared minus 2QR cos of P. Does anybody agree that you could simply substitute it like that? As I had said to you guys, you don't have to name them as little r and big R and you could continue with this kind of momentum where you keep them as they are named in the triangle, right? This is your step. You will substitute your values accordingly. You will find a QR squared of 149.42. And when you find the square root, that gives you the length of QR over here as 14.2 centimeters. Guys, just a quick one. Remember when I said to you that there's a relationship between sides and angles? We have a 70-degree side here, angle, and we know that the sum of these two must be 110. We also know that this is not an isosceles triangle. Okay, Umulim was asking me to revert back to the previous slide. Right. Here's our previous slide, Umulim. Is this the slide that we're talking about? Okay, perfect. Glad I could assist. There we go. Oh, guys, these slides will be posted up for your perusal, guys. So don't be worried, okay? Don't fear. Everything will be posted up. The whole lesson will be on YouTube, available as a recording for you guys. So you can still access the stuff afterwards. Okay, so I was telling you guys about the relationship between sides and angles. I'd said to you that here, this is basically going to add up to 110, but it's very clear that we're not sitting with a 55, 55, that this is not an isosceles triangle. So when you kind of look at it, you know that one side is definitely going to be longer than the other side. And I'm posing to angle, right, bigger than the other angle. And I'm posing to you that this angle, angle R, will be bigger than angle Q. The reason I'm posing that to you is because I'm looking at the side, right? The smaller side goes with the smaller angle. The larger side goes with the larger angle. And as you can see, the 70 degree is our largest angle and it goes with our largest side. Hope that makes sense, guys. So yes, we had calculated QR and we had come to that. That's our cosine rule. Guys, this is literally as straightforward as it gets. The issue is how it gets asked in a question, because you need to be able to spot when you are actually being asked to apply this rule. We'll do some working out questions for the whole of next week. As I said, please send me your questions if you've got special questions you'd like us to have a look at. I've put in a second example for this cosine rule where I'm saying let's determine an angle this time as opposed to a side. So in this case, we've been given 3 sides. We've been given scenario number 2. And we're going to find an angle. Does anybody know how we do this? Anybody? We have our formula, right? Again, I could say little a, little b, and little c. We have our formula, our cosine rule, and we can easily then substitute a, b, c, and substitute b, c, right? Because if you rewrite this, you could rewrite it like that. Agreed. If we had to say we want to leave our unknown on the left, that's easily how then you could rewrite this, right? And then we come and we substitute all our values based on side A being 7, side B being 8, side C being 5. And we substitute it accordingly, and we come out with a cos A of a half. Take our calculator, cos to the power of -1, and we find that our angle A is 60 degrees. Literally just like that. And that is the cosine rule. So today we've covered the last topic of trigonometry. We've covered the area rule, the sine rule, and the cosine rule. That's just about as straightforward as it gets. I'm giving you guys some time to write down some of your homework questions. Please make an effort to get hold of these slides because there are quite a few questions. So just to give you an example, this is your area rule questions. These are your sine rule questions, and these are your cosine rule questions, right? I've set up questions for you guys because tomorrow, the purpose of tomorrow's class is for us to go through these questions. There's a bit of Euclidean geometry here and there. So I'm just going to give you guys time to quickly document. And I see a 4 where it should say triangle. This should literally say triangle. Okay. You can just document this a little. Come prepared for class tomorrow. I think the class is always better when we are prepared. Like Imita just saved me from a storm today, for example. So when you guys have had a first glance and a chance to work out and you're interacting, then we also minimize me needing to come for the next class and say to you guys, oh guys, we made a mistake yesterday, because not everyone is able to attend every class every day. So I'm literally going to keep this up for another minute before I move to the next slide. While I do that, I'll just continue also making my usual announcements, right? My first announcement, thank you guys for joining us. Please continue to share the link with your other classmates. It would be so great to have bigger coverage for mathematics. I think mathematics is so much fun, guys. I'm not saying this because I teach it and I grew up in a family that teaches math, but I think mathematics can be so much fun. My wish is to actually get you guys enjoying the process of thinking and not necessarily concerning yourself with the final answers, right? I'm hoping that so far what we've done, we've gone through trigonometry as an entire topic, and we've taken it step by step. And what we're going to do next week is go through some questions, right? I'm hoping that you guys are still okay with the method of teaching that I've been using. What I need from you, please, is feedback. If you guys would like me to do something better, maybe take things slower or take things faster or have more difficult examples, whatever feedback you have for me, please give me that, because that is what I'm going to use to make this the best possible experience for you guys. Okay, I'm going to move on to the next set of questions. Also, what I want to say to you guys is, I depend on your interaction a lot. Guys, I'm going to go back to the Imita example. Imita just saved me for something I didn't see. I mean, I prepared those slides on the weekend, but I still missed that era. I looked at those slides last night and this morning, and I still missed that era. So I need your interaction, guys. I depend on your interaction for you guys to show me we're working together. We're a team, and we are going to basically be doing a lot of this for a lot of the time, right? So I hope we are having a good maths experience to date. Please ask your questions. Guys, I worry that you guys are afraid to ask your questions. Please don't be afraid to ask your questions. Please ask your questions. I depend on your questions to understand whether I'm moving too fast or slow, or whether some points I'm taking for granted. We are preparing to move into a new topic, and I would like to move into that topic having taken into account all your pointers. Okay, guys, in the interest of time, I'm going to move to the last slide. Then we have the cosine rule. These are your questions. This is your homework. If you didn't catch everything, it's not a problem, guys. We will be going through these tomorrow in class together anyway. The purpose of tomorrow's class is to go through all of this, and then you guys can have your long weekend. From Monday, we'll be doing trig revision for the whole week. Okay, so yes, guys, also wish to mention, I think most of you know that had you gone back to school at the beginning of term 2, you guys would have started with functions, right? So what I'm doing is I'm doing functions next. I'm doing it so that when you do go back to school and you start trigonometry, you guys are a bit ahead in your trigonometry, better understanding, better grasp on things. Please, please, that's what I'm saying. Please, please, please share the link where you can. Those of you who are shy to speak in class need to get a hold of me. My Twitter account is at _Mbaliti. And always importantly, what I always say to you guys, it is lockdown. It is a difficult time for all of us. Please be kinder to each other. Please be kinder to yourselves. Please drink your water. Please sleep. Take care of your hearts and be good. Okay, guys? Whatever religious practice you have, you stay with that. Ramadan, to the guys that are fasting, good luck to you guys. All the best. Be blessed. May you come out of this stronger and better people. Okay? So yes, guys, this is your homework. We are done. Thanks, guys. Cheers.